Okay. So now we were discussing the reactions of alcohol, right? Now listen. We will be going to the second reaction, that is reaction 2. This reaction 2 is actually acetylation of alcohol. Acetylation of alcohol. Okay. Acetylation of alcohol. Now listen. Substrate used for this reaction is we will straight go into the details of this reaction. No need to write these things, these are rubbish. Listen. Now the point is this, actually suppose this is acetyl chloride and this is suppose an alcohol. Actually what happens is this is acetylation reaction, right? Okay. So in acetylation reaction, what happens is this, actually this HCl is lost and this is the main product. Now listen. Now we will study in details the mechanism of this acetylation reaction. Now we'll study in details the mechanism of this reaction. Now listen with all your attention possible. Now the mechanism behind this acetylation reaction is this, that so what will happen is, actually now listen. So this is actually the mechanism, that is this is acetyl chloride. Now listen. Now step by step we will understand, that is this is one sigma bond and this is one pi bond, right? This is sigma and this is pi bond. Now this pi bond is now delocalized because this electron is in dire need of this oxygen is in dire need of electrons, so it will shift the pi electrons towards itself. So that's why this electron is becoming negative. Now listen, this lone pair of electron over the oxygen atom is attacking this carbon plus center. Why it has become plus? Because these electrons are lost. Now listen. Now we will come to this stage. Here we see that this hydrogen is lost as H plus, okay, and this chlorine, being an electronegative element, will try to attract the bond pair of electron towards itself, and this chlorine will be lost as Cl minus. So these two will actually form this. And the rest of this we know. This is what? Acetylation product. Okay. So this is the basic mechanism of acetylation reaction. Okay. And now listen, point is this, you need to understand that this is actually an ester, right? Point is this, you need to understand is that if we use, okay, now listen, let's talk in details. Now listen, I was thinking that it was previously discussed, but still, now listen, you should understand one basic thing, that is, in case of acetylation of alcohol, there is a problem. What is the problem? That primary and secondary alcohols gives ester, tertiary alcohol also gives ester, but that ester immediately reacts with HCl to give acid and alkyl chloride again. Okay, that is the problem. That is, primary and secondary alcohols. Okay, let me rub all these things and then I will discuss the important things. That is, primary and secondary alcohols give esters. When acetyl chloride is made to react with these alcohols. Now, what is the difference between 1 degree, 2 degree alcohol and 3 degree alcohol with respect to acetylation reaction? That is, when acetyl chloride is made to react with these alcohols, then they will give ester. But when 3 degree alcohols are made to react with acetyl chloride, then they will at first give rise to ester, no doubt, but then they will react with HCl to form acid. Okay, at first they will give ester, but then they will react with HCl to give acid, right? All right. Now, so what is the basic difference between 1 degree and 2 degree alcohol? That is, if in a test tube you have given 1 degree or 2 degree alcohol, and in that you have given acetyl chloride, then it will give ester. But if in a test tube, if you have given 3 degree alcohol and together with that acetyl chloride, then you will at first get ester, then ester will react with HCl, then ester will react with HCl, then ester will react with HCl to give what? Acid. That's the difference. Okay, so that is the difference. Now we will try to find out that why this is happening. We already know how 1 degree and 2 degree alcohols react with acetyl chloride to give ester. We already seen the mechanism. Now we'll try to find out that how this acetyl chloride reacts with 3-degree alcohol and why this 3-degree alcohol is converted into a acid. Right? Now listen. Now we should understand the basic, that is listen, suppose this is a 3-degree alcohol. Suppose this is a 3-degree alcohol. Now listen, so this will go here and it will come here, sorry, it will come here and it will go here, so the net result is this. Okay, now listen, this compound is highly unstable. Okay, this compound is highly unstable because of the fact that there are 3 plus I effect containing group. So that's why these plus I effect containing groups will try to push more electron towards this carbon, and these try to push more electron towards this carbon, and this electron will be taken up by this oxygen, this happy looking oxygen, right? Now listen, now this happy looking oxygen therefore is highly polar. Okay, now the point is this, you need to understand that as it is polar, so that's why it is becoming negative, and we know HCl being a strong acid will readily dissociate into H plus and Cl minus. So this is already negative in nature, so this will actually come out as CH3 COOH. Okay, and this whole thing, that is this whole thing, this whole thing will come out as okay. Now listen, so due to the acidic property of HCl, what we are saying is this, due to the acidic property of HCl as well as plus I effect of this CH3, that is the alkyl groups, we are finding out that this product is becoming unstable. Now if we want this product, suppose we want this product, we at any cost want this product, so what we will have to do is this, we will have to neutralize HCl. We will have to neutralize HCl, right? So how we can neutralize HCl? By giving another what? Weak base. What is that weak base, you know? Listen, if we want to get ester of tertiary alcohol, then we will have to add a base like pyridine pyridine or we'll have to add a base like that of what? Pyridine or dimethyl aniline or dimethyl aniline, pyridine or dimethyl aniline. That means suppose okay, wait, I have a good idea. Now listen. Suppose for example there are two test tubes. Now listen, to this test tube you have added two things, that is tertiary alcohol plus you have added what? You have added acetyl chloride. Now what you will be getting? You will be getting what? Acid plus acid chloride, right? Because we know it is unstable, that's all, right? Now in this test tube we have added both of these, that is tertiary alcohol plus acetyl chloride, but we have also added pyridine or diethyl aniline. So what will happen is this, we will get here ester, right? So to get the ester of tertiary alcohol, we need to add something extra, that is pyridine, which is a weak base. Okay. So we have discussed already the reaction between acetyl chloride and alcohols, right? Now we'll be heading towards reaction with Grignard reagent. Okay, listen. Now you know reaction of alcohol with Grignard reagent. Now listen with all your attention. Listen. The first thing you need to understand, that is alcohol is an acid here, okay, and Grignard reagent, that is alkyl magnesium halide, is actually a base here. So it is an acid, alcohol is an acid here. Now listen, as it is an acid, it will give H, and it is a base,